In this video, we're going to talk about variables and review the display and how to use the two together. So let's jump right into it. This is for, we're using this for a challenge called auto attendance. It's popping up here. You're not going to see the challenge till you download to Robot, and we really need to do that because once we download to Robot, we will have our debugger windows available, and we're going to need for this program the NXT remote screen. Let's do this again. Debugger windows. It's under Robot, debugger windows. Go to NXT remote screen. When I click on that, this pops up. This allows us to see what the robot would display on its screen. So we're going to need that. And you remember that you won't see these debugger windows until you actually had downloaded a program, which I just did. And we're going to learn today about variables. And this program, auto attendance. And in auto attendance, this is supposed to be a robot taking attendance in school. The books are supposed to be students, and the robot's supposed to go around and see how many students are in their desks, which are these rectangles on the board. It's supposed to use sonar to see whether or not there's a book in front of it, and B, count it up whenever it does see a student in a desk. Count that up and tell us at the end how many students there were. Fine. So, one thing we need was the debugger window, NXT remote screen. So this is how we're going to see what's being counted up. But then in addition to that, we're going to need a variable to do the counting. We actually are using two separate variables here because in this program we need to keep going until we've looked through all the desks. So this is one row of desks, two rows of desks, three rows of desks. So I have a procedure that I need to do 3 times, and that's where this first variable comes in. Int stands for integer. So this is an integer variable called count, and it starts at 0 because right now we haven't done the procedure at all. And once we do the procedure once, we're going to add to this number count, and count is going to become 1. And then once we do it twice, it's going to add to that, and now it's going to count becomes 2. So let's see how that works. We start count as 0, and it's only going to be an integer, so that means it could be 0, 1, 2, 3, 15, but it can't be 17.63. It can't be a decimal. And a lot of times you can use variables in loops or in other conditional statements. So now in the past, our while loops had used sensors as their conditions. So here's our while, right? Repeat again and again and again and again and again. But what's the condition that controls how long we repeat? It's whatever's in the parentheses, and that was our encoder in this case. The encoder's counting up how many times the wheels have spun around. Fine. Keep doing this stuff until the encoder counts beyond 600. Fine. That's using a sensor to control how long we repeat something. But I could use a variable to control how long we repeat something. So here's my while saying, do whatever's in these brackets again and again and again and again and again. And it's a lot of stuff actually. All the way down to there. I think it actually might go one more step. But let's take a look at that. So it's repeating all this stuff. How long? How long should it keep repeating all the stuff that's inside these brackets? It should do it as long as count is less than 3. Well, right now, the beginning of the program counts 0. Well, that's less than 3. So do all this stuff. What is all that stuff? That's basically going out here, turning left, turning right, and seeing whether there are any students in that book. That's what all this does. Checking whether or not there are students there. All right? Once it does all that, it says count equals count plus 1. Well, remember, count had been 0. Now count plus 1 makes it 0 plus 1 equals 1. Now count is 1. Jump back up to the top. Look at my while and say, hey, is count less than 3? It's 1 now. Yeah, that's less than 3. Do it again. Get to this. Count equals count plus 1. That makes it 2. Go back to the top. Check my condition again. Is 2 less than 3? It sure is. Do it again. Add 1 more to it at the bottom. Now count is 3. Go back to the top. Check whether count is count less than 3. Is 3 less than 3? No, it's not. So at that point, what happens? It had been repeating all of these things, and now it's going to go past this to the end. And now that's nothing. So the whole program ends once count becomes 3. When it was 0, 0 plus 1 is 1. Does it again. When it was 1, 1 plus 1 is 2. Less than 3. Do it again. But when 2 plus 1 equaled 3, then that condition is no longer true because 3 is not less than 3. So it's going to go past this bracket, and instead of going up and checking again, it's going to see what's next. Well, there's nothing next. The program ends. Fine. But in this case, we also needed to know, and let's run this just to see. We're using this remote screen, and we're using display text line, and we had talked about this before. Here was our variable count, and down here on this line, we have 2 displays, but let's take a look at this one. This display text line will make stuff pop up on this screen. And you put what you want to pop up in the parentheses. The number 2 tells it which line it's to be put on. There's 5 lines we can choose from, so that's going to go on the second line. Then you need a comma, and then in between the quotation marks is what's actually going to be displayed on the screen. Normal words, like the word count here, will actually just pop up as count. It will be itself. But this special set of letters, %D, tells it don't display %D here. Display some value that has been created somewhere else in the program. And we then close the quotation marks, put a comma, and then say, this is what we want to, this value that is equal to count is what we want to have displayed on the screen. So again, that's this, all right? So it's a little bit confusing, but this first count is the word count. So we're going to see the word count up here, and then the equal sign is also just a regular word, but then instead of %D, it's going to put up on the display the value of count at any given moment. Well, count, remember, is going to change. It's going to start out as a 0. But then every time we do this procedure, it's going to add 1 to count. So count should start at 0. Then it should, when it displays it later on, it should be 1 because we added 1 to count. Then it should be 2. Then it should be 3. If it gets a 3, the whole thing ends. And similarly, I created a variable called students. And I don't want to go too much into this, but that's this line right here. Display text line is going to print something. It's going to put it on line 3. Then it's going to say students equal %D is some value, and we want the value that the variable students is equal to. Students also starts at 0, but if we see any books in these desks, that student variable should go up, and it should equal the number of students in all the desks. We'll quickly go over how that's working in the rest of the program, but basically here's the way that works then. we're going to say while count is less than 3, keep doing this whole thing of finding the students. How do we find the students in this program? We are using an encoder, and first we want to go straight. That's this, okay, for a couple of rotations. Goes forward, then we reset the encoders to 0, then we turn, while it's less than 170, we turn right. One motor forward, one motor backward, okay? And so that's going to turn right. And when it turns right, now notice, here was my open bracket, and we turned right. At that point, when we turn right, we want to take a look. Is there a student there? So that's where my sonar comes in. If the sonar is less than 40, it means something's in front of it. And if that happens, we add 1 to students. That's where we're counting the students. And at that point, we also are going to say, hey, if the number changed, we want to see it. So print on line 3, students is the new number of students, which presumably be 1. Okay, we checked using the sonar at that point. By the way, if it wasn't less than 40, it would never do this. Okay? If sonar was 50, 60, 70, 200, then this if never happens. It says, okay, well, no, it's not less than 40, so just jump past this and check the next thing. And if that happens, we are now turning left to check the other desk. That's what this does. And what do we do again? If the sonar is less than 40, let's add 1 to students, because that means there's something in front of it. Something's kind of close to the sonar. If not, we don't add 1 to students. We go and we turn back to straight. That's what this does. It's kind of a lot. And we say, okay, we've checked now. So what would that have done? That would do this. What we've just gone through. We go forward. We turn right. We use the sonar and check. We turn left. We use the sonar and check. What happened up here? When we turned left, there was a book. Sonar became less than 40. It saw that there's something there. It was a 20 or it was a 10. It was a 35. Something less than 40. If that happened, then going back to this, if the sonar was less than 40, it was going to add something to students right here. So that's why when it turned left, the sonar saw something that was less than 40. Therefore, it added 1 to students, and then it displayed that on the line, and that's why we see here students is no longer 0, it is now 1. Okay, but remember, we want to check all 3 rows. So count is now count plus 1 when it gets to the end. We've checked this row, we add 1 to count, and we do the same thing here. Now it's continuing. Why? Because it went back up here to the while count is less than 3 and said, is count less than 3? Yeah, because it started at 0. It is now 1. Right there, we're displaying it right there. We're seeing the count variable. By the way, we see the count variable right away because when I added 1 to count, I included a new display that replaced the old one. And if you print something on the same line, it will write over top of it so that you won't see the old thing. So now that we added 1 to count, count is no longer 0, count is now 1. And then we go up and check our condition. Is count less than 3? 1 is less than 3. Do the whole thing again. So it's going to go forward, turn right, use the sonar to check. If the sonar is less than 40, it is adding 1 to the students. And it did. And then it's going to turn to the left. And because there's nothing there, sonar should stay big. If we look down here, it's 260. And so, yeah, that's not less than 40. So therefore, don't add 1 to students and keep on going. And we get to the end. Checks, there's no students there, so it doesn't add. And now it has done the procedure 3 times. It goes up to this. It says, are we less than 3? 3 is not less than 3. End the program. Unfortunately, this program does not work